So I'm going to begin this conversation about trigonometric ratios, and you might be like, what is he talking about? Well, I'm going to go back to maybe grade 7, grade 8, and grade 9 and talk about similarity. Now, similarity is the idea of making a miniature version or a enlarged version of an object. So I'm going to start off with my basic 3, 4, 5 triangle. And this holds true for every triangle. Now, I know that this base angle is going to be the same. What do you notice about all these triangles? Well, what you should notice is that all the sides are proportional. That is, we could call this triangle 1, and then what did I do to get triangle 2? I just multiplied all the sides by 2. I'm going to call this triangle 3. Well, how did I create triangle 3? And triangle 3 is just basically triangle 1 multiplied by 3. The side lengths are multiplied by 3. But if you recall grade 7, grade 8, grade 9 thought, is that the shapes remain similar. And specifically to triangles, the angles are going to remain the same. So right now I wrote the blue angles as theta. And what's so interesting about theta is that if you take the ratio of sides, they're going to be the same. So I'm going to take the ratio of this and this. That ratio is 3 over 4. Now I'm going to do the same for each triangle. So that ratio is 6 over 8. What 6 over 8 simplifies to 3 over 4. So the same angle will have the same ratio. Now here, let me go to triangle number 3, and we enlarged it by a factor of 3. But the ratio of the opposite side over the adjacent side is 9 over 12. And if you simplify that, that simplifies to 3 over 4. So for each of these similar triangles, the ratio of the opposite side over the adjacent side is 3 over 4. And really, this is how our conversation of trigonometry is going to begin. We're going to just talk about the ratio of the sides. Now the ratio of opposite over adjacent, I'm going to call it tangent. However, if I switch up the ratios and call it opposite over hypotenuse, I'm going to give it a funny name like sine and just call it the ratio, sine. The adjacent over hypotenuse is going to be called the cosine. And from now on, I'm going to say, well, the cosine ratio, and everybody in the world is going to take the adjacent side and then divide it by the hypotenuse side, and that's the cosine ratio of an angle.